In section 6.3, we are going to look at specific properties of logarithms. Remember last time we said the answer to a logarithm represents an exponent. So if I gave you something like log base 4 of 16, and I said, hey, what is this answer? This is asking 4 to what power is 16? So that power would be 2. So the answer to it would be 2. Since we're going to be building up to solving equations with logs in them, this section is some useful simplifying properties that will make solving easier. So all of our objectives today have to deal with these simplifying properties. So there's going to be 3 of them. And they're kind of funky how they work. So this first one says, if I have log base b of 2 quantities being multiplied, I can actually write that as 2 logs so it's like the x and the y each get their own log with the same base as the original. And I now have addition between them. Mathematically, these 2 quantities give you the exact same answer. If I were to actually have values for x and y, if I did this side and I did this side, they would be equivalent. I know they don't look equivalent, but mathematically they would be. The next one, if I'm dividing, I can expand that into 2 logs. But it will expand into the operation of subtraction. It's almost kind of like our exponent rules that we talked about at the very beginning of this class, where if we were dividing, we subtracted the exponents. If we were multiplying, we added the exponents. It's hinging off of that property. Now the last one is the goofiest one. If I have the log base b of x and it's raised to some power, in this case we'll call it p, what that is equivalent to is this expression. So it looks like the exponent just simply moved forward. What? That seems like something that someone just said, hey, you know what, I'm just going to move it forward and call it good. Mathematically, there is a reason why you can do this, and I want to quick show you why this one works. So if I had something like log base b of x cubed. Well, according to this third rule, I could just write that as 3 log base bx. I could simply move the exponent forward. Now, why does that work? Well, watch this. This log base b of x cubed, hopefully you agree, I could write it like this. X times x times x. That's what x cubed is. So if I were to expand this using my first rule where it says, hey, if they're being multiplied, I can break them up using addition, it would look like this. I would now have 3 logs. And finally, if I combine my like terms, because they are like terms, if I add them together, I would have 3 of them. So all this third property is, it's a shortcut versus if we were to do it out this long way. So yes, mathematically, it does work. There is a reason for it. It's not just something we're doing because someone made up. There is a purpose for it. So let's try some of these here. Expand each expression. So I want to expand the logarithm out as far as I can get it to go. So this first guy, what I tell my students to decide first is how many logs will this break into? And to decide that, you want to look at the stuff inside the log. I have a 12. I have an x to the 5th. And I have a y to the negative 2. You're looking at the things that have multiplication in between them. That kind of separates the pieces. So I have 3 terms. So that means I'm going to write the word log 3 times. I'm going to break it into 3 logs. The first one will have a 12. The next one will have an x to the 5th. And the next one will have a y to the negative 2. They each get their own log. Because there was multiplication between them, that's that first simplification property that says, hey, we'll now use addition. And the last thing that I would want you to do is to move forward any exponents. So on this first one, sometimes people are tempted to move the 12 forward. No, that's not an exponent. So that's going to stay log 12 plus. Now the next one, I'm going to move my exponent of 5 forward, so I get plus 5 log x. And the last one, I'm going to move my exponent of negative 2 forward, so I'm just going to write it as subtraction. Here is the expanded form. Now by itself, this really serves no purpose. But when we get into solving, you will see that sometimes it's easier to expand a log first before solving, and it will actually make it easier to do. So some of these answers today are going to be long answers, depending on what's involved. Okay, let's look at the next one. So my first question would be, how many logs is this going to expand into? Well, let's see. We have a 10. We have a t squared. We have a u. And we have a v to the negative 3. So it looks like there's going to be 4 of them. And when you break them apart, each of these logs will have a base 4. So log base 4 of 10, log base 4 of t squared, log base 4 of u, and log base 4 of v to the negative 3. Because there was multiplication in between all of these terms, I know it's going to expand into addition. And the last step, I would want you to move forward any exponents that can be moved forward. So the first guy is done because 10 is not an exponent. The next guy, I can move my 2 forward. The next one with the u does not have any exponents. And the last one, I'm going to move my negative 3 forward. So this would be my expanded answer. All right, let's look at this next guy here. The natural log of x squared divided by the square root of 4x plus 1. Natural logs work the same way as regular logs because they are still logs. So let's first rewrite this guy. If there's a square root involved, I don't want to write it as a square root. I'm going to write it as the 1/2 power because that's what a square root means. It's the same thing. We want to work with exponents. Okay, so if I expand this, my first question would be, how many logs would this expand into? Well, for sure we have 1 up here. And now here's the tricky part. This entire thing, because the 4x plus 1 is inside of parentheses raised to the 1/2, that has to stay as one thing. So this problem is actually only going to break into 2 logarithms. I'm going to have a natural log of my x squared, and I'm going to have a natural log of 4x plus 1 raised to the 1/2. That 4x plus 1 cannot be broken apart because it's in parentheses raised to the 1/2. It has to stay together. That addition really screws things up. Next, I would ask, what operation is between these 2 logs? Well, since it was division, that expands into subtraction. And the last step would be to take care of any exponents. So I'll move the 2. And I'm going to move the 1/2. When you move the 1/2 forward, make sure to keep the 4x plus 1 still in parentheses. because we need to show that the 4x and the 1 are inside of that log. Otherwise, if you write it like this, it might look like just the 4x is with the natural log, but we need to make sure to tell it, no, the 1 is also inside. So this would be my expanded answer. Next one. How many times will I write the word log on this one? Well, because of this darn addition up here, I want you to think of that in parentheses. That has to stay as one piece. That we can't break the addition up. It's only multiplication. So that 3y plus 2 has to stay as one thing. Then there's a 4. And then there's the cubed root of y. So this one's going to have 3 logs. So I'll have natural log of the 3y plus 2. That's one quantity. I'll have natural log 4. And then I'm going to have natural log of y. And real quick, if I had rewritten this so that I didn't have a radical, the cubed root of y, if there's a 1 technically here, remember that's the same thing as y to the 1/3. So that's how I'm going to write it in the expanded form. Okay, now I need my operations. So between the first two, well, it was division. So I'm going to use subtraction. And here's where people really get confused. What operation goes between the final two things? Well, you might say, well, it's addition because there was multiplication between them. I would agree, except if you want to write it like that, then you need parentheses showing that both of these second items were technically being divided. Both were on the bottom. So this subtraction has to apply through. So what we would actually get is a negative natural log 4 and then a minus, and I'm going to move the 1/3. This would be the expanded form. That negative distributes. What I tell people, a good rule of thumb, if you don't want to mess with the parentheses and you want to go straight to the answer, if the expression is up top, it's going to have addition. If they're sitting in the bottom, they will have a minus in front of them, always. If they're sitting in the bottom, they will end up having a subtraction sign in front of them. Okay, let's look at this guy. How many times will I write natural log? Well, we have a 3. We have an a to the 4th. We have a b to the 7th. We have a c. And this entire quantity on the bottom has to stay together. So I'm going to have 5 logs. And before I do that, I'm going to quick rewrite this just so we can see the pieces. And on the bottom, instead of the 4th root, I'm going to write it as b minus 9 raised to the 1/4. Same thing. All right. So we have natural log 3, natural log a to the 4th, natural log b to the 7th, natural log c, natural log b minus 9 to the 1/4. 5 of them. Now let's figure out the operations between the first two. Should be addition, because they're up top and it's multiplication. Next set should also be addition. Next set should also be addition. But the back set should be subtraction because it's being divided and it's in the bottom. The last step would be to move any exponents forward. I cannot move the 3 forward because that's not an exponent, so natural log 3. The next one, though, should be 4 natural log a. Next one, 7 natural log b. Natural log c. The last one, minus 1/4 natural log b minus 9. So this is an extremely long answer. Okay, the next one is small but deadly. Let's rewrite this first instead of using a radical. Square root is the same as the 1/2 power. So how many times would I write the word log on this one? It's going to be 2 of them. What operation will go between them? It should be subtraction because they were being divided. And the last step is this 1/2. Well, what's going to happen when I move the 1/2 forward, it's going to sit in front of the whole thing because they were both under it. Or you could write the answer like this. Either one is acceptable. You can distribute or you don't have to. And that one is done. All right, now the other objective for today is called condensing an expression. And this is the exact opposite of what we were doing. Rather than breaking it apart, we're going to squish it back together as one log. Because what we'll find is some problems are easier to solve when they're condensed versus when they are expanded. So, how do I even begin? Well, we're going to do everything in reverse. So notice these numbers sitting in front of the logs. They are going to turn back into the exponents. They turn back into the exponents. And then the last step, rather than having multiple logs, I want my final answer to just use one log. So when I condense these together, are they going to multiply together or are they going to divide? Well, since it was addition, they're going to multiply. This is the condensed answer. Notice in my final answer, you only see log once. One log, condensing it down to one thing. Let's try the next one. So my numbers in front are going to turn back into the exponents. Okay. Next, I'm going to condense it down to one log, and it's going to be a log base 3. And will these condense into division or multiplication? And we should say division because they're subtraction, so I'll have my x to the 4th over my x plus 6 to the 1/3. I would be fine if you got it to there, but there is technically a little bit cleaner way to write this answer. Instead of writing it to the 1/3 power, if we turn it back into a radical, that's a cubed root. Just doing the exact opposite of what we were doing on the expanding problems. And it has been condensed. Notice in my final answer, there's only one log. The reason why I stress that, sometimes when people condense, I'll see something like this. This would be wrong. Okay, that mathematically, that means something different. When you condense, one log, one single thing. Okay, next item. This time we have 3 of them. Let's move exponents first. So this first guy, there's no exponents to move, but now I'm going to move the 3, and I'm going to move my 7. Okay, now we're ready to condense this into one log. So log. So between the first 2 guys is addition. So what operation will that become? Multiplication. Between the back 2, there was subtraction. So that's going to become division. And again, a good rule of thumb, and this will not steer you wrong, if there's subtraction in front of it, that item must end up in the denominator. If there's subtraction in front of it, that item must end up in the denominator. So here would be my condensed form. Let's try the next one. Notice on this one there's no exponents to move, so we're ready to condense it. And what operation would this condense to? Should be multiplication. Now, since these are both just numbers, let's simplify this. So I actually did the multiplying, and we're going to go even further. Because I have just solid numbers, I have no variables, we can actually turn this into its answer. This is asking 4 to what power is 64? So the best, simplest answer would just be 3. So this one is an example of what I mean by some logs are easier to simplify when they are condensed, because then it's easy to see, oh, this would turn into 3, versus its original form, it's really hard to spot that that's 3. Okay, so simplify them as far as you can. Next guy. You know what? Actually, to make this easier to look at, I'm going to flip-flop this whole thing, so I'm going to write it like this. Okay, so I just rearranged it. I like that subtraction to be in the middle. Okay, so let's move exponents. And now we are going to condense it into one log. And because there's subtraction, this is going to become division. Now, I would probably accept this answer, except there's one thing that you can do to make it a little cleaner. Because I just have a quantity up here, 6x being cubed, I could actually just cube that. So when I cube 6x, 6 cubed, I could just write it as 216x cubed over x plus 1 to the 5th. If you don't do that, then I will be very picky. You need to make sure that the 6x is in parentheses to show that that cube affects the 6 and the x. Okay, and the last one here. For now, we're going to come back to this 1/2. For now, let's ignore it and work on the inside. So there is an exponent to move. I'm going to just write it up here. So that will be natural log of x to the 4th. So when I condense this, I'm going to have natural log. Between the first two guys is subtraction. So that should be 3x plus 5 divided by my x to the 4th. And this last guy also has subtraction in front of it. And remember what I said, if it has subtraction in front of it, it should end up in the bottom. So it's going to end up next to the x to the 4th. Now we're not done, because I still have to worry about this 1/2 that was out front. So if that turns back into the exponent, so like this whole thing is raised to the 1/2, that's the same thing as just doing this. The whole thing is under a square root, because remember the 1/2 power is the same as a square root. And this one is done. Okay, I just want to practice some simplifying here. So if I want to simplify something like this first guy, if there's a radical involved, let's rewrite the radical first. So that is the same as the 1/5 power. To make it even easier, let's use our exponent expanding trick to move the exponent forward. And by doing that, if we focus now just on the log part, that's asking 4 to what power is 64? Well, that's 3, but I still have this 1/5, so they multiply together. So this final answer is 3/5. Look at the next one. Let's move our exponents forward. So 5 times 2 would be 10 natural log e minus 3 natural log e. We know from our previous unit that natural log and e, it's like they cancel each other out, because this is a base of e, so they cancel. So this problem becomes 10 minus 3, 7. So these expanding properties, especially where you move the exponents, can make simplifying a lot easier. Let's look at the next guy. There's a radical involved. So let's rewrite it without the radical. So that would be the same thing as 27 to the 1/2 power. Now what? Well, let's get rid of that exponent. Move it forward. So when it moves forward, it's going to multiply to the 2. So what's 2 times 1/2? 1. So it's basically gone. And now we have a nice simple logarithm to solve. This is asking 3 to what power is 27? And it should be 3. Next one, let's move our exponents. So 9 times 3, I'd get 27 natural log e, and I'd get 20 natural log e. We know natural log and e cancel. And I get 47 when I add them together. Okay, the last thing for today is something called the change of base formula. For example, what this refers to, if I gave you something like this, log base 4 of 7, and I said, hey, give me that decimal. What is this decimal answer? Well, we know this is asking 4 to what power is 7? Well, it's going to be a decimal because 4 to the first is 4, but 4 squared is 16. So this answer is somewhere between 1 and 2, but it's a decimal. And I told you last time, your scientific calculators, the log button, can only be used if it's base 10. So I can't just, in my calculator, I can't hit log 7, because if I do log 7, when you use the log button, that's base 10, and this is not base 10. So how do we get this decimal then if my calculator only has a log button for base 10? Well, it turns out there's something called the change of base formula, and it says, hey, if you have a log with any base, I don't care what the base number is, you can actually rewrite this as log x divided by log b. Now, why is it called the change of base? Well, in this new form, the bases are now base 10. And that is something we can work with. So let's try this first example. I would have your calculator handy to make sure you can do this. Evaluate each logarithm. So I want this decimal answer. So let's rewrite it first as log 5 over log 3. A way to remember, like, oh, does the 3 go on top? Does the 5 go on top? Which one goes where? The base number is always on the bottom. Base on the bottom. Base on the bottom. So now this is what I would want you to enter into the calculator. So if you hit the log button, it's going to look like this. So then I would do 5, close that parenthesis, and then hit the divide button, and then hit the log button again, 3, close the parenthesis, and hit enter. And if you do this correctly, let's go 2 decimal places. This answer should be 1.47. 1.47. Okay, let's try the next one. Log with a base of 1/2 of 6. So using my change of base formula, that would be log 6 divided by log 1/2. See if you can get this one to come out. So in your calculator, you'd hit the log button, and then 6, close the parenthesis, divided by log, parenthesis, you can either do 1/2 or 0.5. And if you do this correctly, the answer that you get out should be a negative 2.58.